Well, hi everyone, and this next piece we're going to be studying the schematic here and trying to get a grip on the wafer switches and how they work. And you know, I've been through lots of radios, like at least a couple hundred, and I've been doing this you know, a lot lately, but all through my life, and I've never ever really studied wafer switches. I've just managed to somehow stay away from them. So what I've decided to do here, I'm going to study this schematic quite thoroughly and take you through it, and I'm trying to develop some notions around wafer switches, so A, I'm not so scared of them, and B, I can analyze them more quickly. So I really let my eyeballs look at this thing for a long time. Here's a few things that I've noticed though. So first of all, here's the wafer switches. 1, 2, 3, 4, 5, 6. So there's 6 sets of rotating wafer switches in the band switch. And they're numbered. Like this is number S4, rear. There's S3, rear. There's S3, front. So you can kind of figure that out. Rear and front. Well, it's really one wafer with switches on either side. Here's S2, rear, S2, front, S1, front, and S1, rear. So we can't see these right now because the radio's not turned over. It's I'll have to flip it over to take a look at this. But now, much earlier on, when I was using the schematic, I noticed these dotted lines here, and I noticed this comment: through connection. Well, I've never read that on a schematic before, so I just noticed it and thought, maybe I'll figure out what that is down the road. Well, now I know what it is. If you see this dotted line here coming down, here's another dotted line here. There's one more. It's a little harder to see this one right here, but look, there's that note, through connection, every time. In fact, this one, the note points clearly right at the line. So, you know, others might be familiar with this, but I'm actually not, because I've stayed away from these things. That means that the rotating center collar, or the contact collar, if you want to call it that, on the front and the back of the switch are actually electrically connected. So the way I think you're supposed to read this is that it is a through connection. That's, maybe they could have come up with something better there, I don't know, but and that also goes with some testing I did earlier, where to my surprise I found what I thought would be a connection right through the wafer. It was in fact not connected right through the wafer, but the front and the back are actually insulated from each other. So, and another interesting thing here is this is S4 rear. I looked and looked and looked. There is no S4 front. So this is the very back of the switch, and some of these connections are interesting. They go into this area I'm concerned about here. Now another thing, I really, you know, sometimes I find I look at this kind of stuff for a long time, and then it's almost like a slap in the face. And here's one of them. So I draw this. So I know. So these coils are oscillator coils here. They're going to control the speed of the oscillator, or frequency of the oscillator. And I follow this wire up. And of course, it goes up where it should. But you know, I should have looked a little closer, because in my mind I had it going up into the what we would call the mixer tube these days. This tube. But in fact, this is where it actually goes. It goes over here to the first RF tube. So that's still a little bit of a mystery to me, just what's going on there. Now I also noticed this. Again, this is a symbol that maybe is used very consistently, and I just never realized it. Now that's the variable tuning capacitor. I have a curved part of the capacitor with an arrow on it. Here's another one here. So I circled the 3 tuning capacitors, and of course that's these 3 sections here. And they're kind of drawn in quite different locations on the diagram. They're certainly not like they are on the radio. It took me a while to find this one here. It's hard to spot. So this is the important one. This one is the one that controls the oscillator. And that's this one here. That's the oscillator one. Now, what I figured out about these switches, and again, maybe some of you have got all this clear in your minds already, and I'm just kind of catching up. I don't know what to think about these switches, to be honest with you. I decided I would track back from the mixer grid, if you like, of the mixer tube. One that has all those grids inside it. That's where they're going to mix the incoming signal from the antenna with the oscillator signal inside this tube. So I followed it back, because this has to lead to all the coils here. And when the push buttons are selected, all the coils here. So I'm just about at the end of my story here that I can tell clearly. Because I'm really finding this really confusing, how this is done. I can't fathom why every coil Boy, I know I have never studied one of these things to death like this. Or maybe it's just something about this particular one. I mean, I have looked at other schematics. I have certainly seen all the coils, and they have not been as weirdly connected as these. That's about the best I can say. So let's look at the top coil here. There's a coil, and it's got a tap. And the top of the coil coming down into the switch in a certain position. So this switch selects the top of the coil. The bottom of the coil goes down here, down here. Oh, no, it's connecting to the tap of this coil. So what I'm thinking is you're switching in more and more coil. That must be it. Okay, so now we can think about the function of the switch a little more. In particular, what is going on with switch 1, what is going on with switch 2, and switch 3 and switch 4. They all have distinct purposes. Now when I look at one of these switches in the back of the radio, up until this moment, I never thought of them quite this way, or what I'm about to, how I'm about to describe them. To me they look like a jumbled up mess of connections, and who knows what is going where. But now I've noticed that in fact switch 1 switches the front end, let's call them RF or antenna coils. And switch 2, front and back, is switching, what is it switching? It's like it's switching right after the, oh no, you know what? Oh, how do you like that? You look really close here. I can bring this down like this, it doesn't cross a wire. So it's very close here, and at a glance you'd think it's all just connected together, but it isn't. This is all part of that tube, and actually the circuit around the RF amp is really pretty darn simple, pretty darn small. Huh. Just things, when I look at these, and I spend a long time looking at them, things, like I said before, kind of pop out, or suddenly I resolve them at a new level. They stop being bunch of lines and they start kind of making a little more sense to me. Well, anyway, going back to what I was talking about. So this section of the switch front and back does one thing, and this does another. And this one down here, along with this, so this is switch 3 front and back, and switch 4, these are switching the oscillators. You know, when I look inside and okay, they're even showing you the shape of the contact piece, where it's wide and where it's narrow, and that's quite common. And that makes these switches really very complex, especially since the front and the back on this is almost like one switch, if you like, because they're connected together. The rings are connected electrically together. That makes it pretty complicated to look at that thing and figure out what it does. I do have a couple ideas for testing. One is to switch between having the push buttons in and having them not in. Just switching back and forth between those two settings, which is basically push button and AM. They can kind of spot where the switch is cutting in and out on these lines. I don't know how that would be helpful, but it could be done. Now, getting down to why the oscillator's not oscillating. If we look at these coils, these are the oscillator coils. It's a very unusual way they're wired together. And this switch, which is selecting the tap wire, each coil has a tap right there, right there. So this selects which coil. I'm still trying to fill in the gaps in my head about how this works. This one is switching the top of the coil. So we might assume that when this switch is in the right position, this line and this line get energized. See, I don't know what's going on with all the rest of it. I don't know. Or maybe the way this works is you keep adding more coil. Or maybe there's some combination of coils in here. So for instance, in one setting it's this coil, in another setting it's these two, in another setting it's these three, in another setting it's these three. I don't know. I have no clue. There's always been this terrible mystery around these switches. I've really wondered how the guys who designed these things, did somebody hand them a switch and they had to use it to achieve this, or did they come up with the switch design they required to perform the switching functions? And I'm pretty sure it's the second one. And then the manufacturer would make exactly what they wanted. Which of course means that every radio, pretty well every radio, has got to, doing its own thing. And you might even see basically the imagination of the engineer inside this stuff too. And, clever guys came up with clever things, and far be it from me to ever really fully understand what one of these is doing. I think that would require quite a few hours of very careful study of each one of them. Compounded by the fact that these are hard to see. I mean, this is not a very great image to work on either. So we know for sure, though, this is the AM coil. And we know the tap from it is going to be switched up through this wire, through these capacitors some weird way, through this thing. Here's the tuning capacitor, that's going to control the actual oscillator frequency. And then on up, through that. Now all the different local oscillator frequencies for the different bands are going to pass through this wire. They all make it except the AM one, so we know the problem's not up there. And I can't imagine it. Could it be around here? I can't imagine. All these capacitors are there for every band. So it comes down to, as I've kind of concluded before, that one, possibly even this. This is on the side of the radio. Gee, I wonder if somebody... They're there, right there. Those holes. The screw's in behind. So that's the one right there. Excuse me. Well, you think that's about enough staring at this thing? I mean, all I'm doing is arriving back at the idea that these capacitors gotta go. We get back on the value of them. That's 5600 picofarad. I don't think I got such small capacitors. And 0.68 picofarad. No, 0.68 nanofarad. Well, I'm going to look for some of these, see if I got some capacitors to replace those too, and then we're going to hunt them down on the radio and change them out. And see what we get from that. Thanks for watching.